Day 2 of functions, we are going to review domain and range, independent and dependent variables, and we'll also look at describing graphs. So can you fill in the following blanks? What kind of values are domain? They're all possible blank values. They're also called the independent variable. And range are all possible blank values, also called the dependent variable. So do you remember from before which letters we look at for x and what letter represents y? And so if you put x for domain and y for range, then you would be correct. So domain is all possible x values, range is all possible y values. An easy way to remember it is x comes before y alphabetically, just like D in domain comes before the R in range alphabetically. So let's take a look at finding domain and range for the following relation. And this relation we can write many different ways. As ordered pairs, we can put those ordered pairs in a table. So 1, 3, 4, 6, 2, -5, and -2, 4. We can draw it as a mapping diagram. A mapping diagram essentially puts the domain in one oval and the range in another, and then it connects them. So here's the domain, here's the range, and then it connects what goes with the 1. So the 1 goes with the 3, the 4 goes with the 6, 2, -5, -4, 4. And I could have put them in any order, my arrows could have crossed. But that's what a mapping diagram will look like. And then a graph, we're going to graph the coordinates. So I'm going to go ahead and graph all these. So we have 1, 3. Here's 4, 6, 2, -5, and -2, 4. All right, so here are 4 representations of the same relation. Again, we have ordered pair, table, mapping diagram, and graph. And then we can talk about the domain and range. And so there's many different ways to write domain and range, and one is called set notation. And so for set notation, they use these curly brackets, and we can say the domain are all the values, and there's my curly bracket, 1, 4, 2, -4. So that set are all my range numbers, or domain numbers, and then my range would be 3, 6, -5, 4. So there's one way to write the different sets when we're looking at domain and range. So domain, the x values, range, the y values. So yesterday, we practiced finding the domain and range of a bunch of different graphs. So let's review that today. For domain, it's how far left and how far right. And so what we did yesterday is I had you, if you had different color markers or pencils or crayons even, if you drew how far left and how far right the graphs go. So here's the graph of y equals g of x. And I'm going to go how far left and how far right. And we say here that x, the domain, is between -4, and it can include -4, so there's the equal sign under the inequality, and it's x, and then the highest number it went to was 5. So this inequality says that our x values go from -4 to 5. And then for range, we look at how low it goes and how high it goes. So here's the lowest it goes at 3, and the highest it goes, it looks like it's at 7, and it does include 3 and 7. So we say our range is between 3 and 7. So that is one way to write domain and range as inequalities. Let's take a look at our next graph. This one reminds me kind of like a UFO, maybe like a helmet. Domain, so how far left and how far right. So here's the left end, here's the right end. And it looks like our smallest x value is -7, and it's a closed dot, so it can include the -7, and it goes all the way up to 7. So here's an inequality that says our domain goes from -7 to 7. And our range is how low and how high our graph goes. So the lowest is -3, the highest is 4. Again, it can include those values. So we say y is between -3 and 4 using these inequalities. Okay, let's take a look at, we have these, they're called quadratics or the parabolas, and let's talk about domain and range for each of those. So domain, again, how far left, how far right. The first graph here goes from 1, and it is a closed dot, so it can include that, to 5. And then the range, the low and the high, again, is from 1 to 5, this time for the y value. Let's look at the domain for our last quadratic right here. And if you notice, it does have arrows on each end. So this graph keeps going all the way left and all the way right. So we say that this x set is all real numbers. So it can go any number to the left, any number to the right. They're all covered by this graph because it keeps going left and right in each direction. So when that happens, it keeps going. We say all real numbers. There is a lowest point on this graph, not a highest point though. So again, there's the arrows that keep increasing, but we can see that the lowest y value is 2. And so we say y is greater than or equal to 2. And then it's everything bigger, so we don't have like the other end of that inequality. So we say y is greater than or equal to 2. You could also say 2 is less than or equal to y. A few ways to write that. Okay, so that's a quick review of domain and range. This is what we looked at primarily yesterday. So today let's look at independent versus dependent variable. And here are different ways to think about these words, independent and dependent. Independent is what you do. Dependent is what happens. Independent is the input. Dependent is the output. Independent is like the cause, and then dependent would be like the effect. And the independent would be like the before, and the dependent is the after. So all different synonyms for independent versus dependent. So let's given the following statements, determine which represents the dependent and which represents the independent variable, and then can you complete the sentences below for each pair. Okay, so let's take a look at the things on the left-hand side. A cell phone bill, the cost of a speeding ticket, how far you drive, how much heat you can use, how much money you earn, so on. And then the stuff on the right-hand side, how cold it is, how much gas is in your tank, how much math you master, how much rain it falls, minutes used, grades on tests, and so on. And let's figure out what depends on what. Oh, so we fill in this table. All right, so let's do some of these together. I won't do all of them. I'll do a few of them so you get the idea. How about this one? The cell phone bill. And what is it related to on the right-hand side? It's minutes used, if you have that kind of plan, I guess. So let's fill it in the table. The cell phone bill depends on your number of minutes used. Okay, let's do another one. How about this one? Cost of a speeding ticket. All right, which one is it related to over here? The speed at which you were driving. Okay, so the cost of your speeding ticket depends on the speed at which you are driving. Okay, I'm not gonna write the whole thing. All right, so let's label these. Our independent variable would be the right-hand side, and the left-hand side would be the dependent. These depend on the right-hand side. All right, so there's a bunch of examples. We just did a few. You can do a few more if you would like more practice. Okay, the last thing that we're going to do today, well, almost last thing that we're going to do today, is we're going to take a look at story problems, and we'll talk about independent, dependent variable in relation to that. So it says, now we're going to watch a video of Adam sliding. Watch the first few times, and then can you sketch a graph of his height over time? All right, so let's take a look at this video. It's called Graphing Stories. Let's see if I can maximize this here. I suppose I can do this, huh? Ah, there we go. All right, so let's watch the video first, and I'm going to play it a few times. We're going to see if you can graph this. I don't think there's any sound. Just the birds. Okay. Ooh, so we should talk about this. What is this? Independent or dependent? Height of waist off the ground. And then the other variable is the number of seconds that go by. And so if you think which one's independent, which is dependent, the independent variable in a graph is the domain. It's the x value. The dependent variable is the y, it's the range, so it's the y value. So if you're ever looking at a graph and I ask you what's the independent and what's the dependent variable, the independent variable is the x-axis, the domain. The dependent variable is the y-axis, or the range. So independent on the bottom, dependent on the side. All right, so let's watch. All right, so we're going to watch it at half speed. Again, look for his waist. All right, so his waist is kind of like where his shirt meets his pants here. So his waist off the ground. So think about, where would your graph start at? What's happening at each of these times in the graph? What happens at the end of the graph? All right, so before we see how they graph it, we're going to watch it again at half speed, maybe like twice more at half speed. So watch his waist, where it is, watch the time, and think about what this graph would look like, or you can start graphing it. All right, one last time, and then we'll talk about, in class we would share our answers, but here we'll just show you what it looks like. Okay, so one more time, see if you can draw this. All right, so if you want to replay yourself, you can replay this video. We're going to move on then. Again, in class, I'd say, all right, what did you guys come up with? Let's put our answers up, and we would show that. Let's see if you guys came up with a graph that looks like Adam's waist off the ground. All right, so I'd ask you to compare your graph. Did you have that little dip when he jumped up? Did you have that kind of when he flopped down on the slide, that decrease in his height right there, and he sat on the slide for several seconds? So do you have a graph that matches? And again, there's many pieces to the graph that we'll study. We'll look at independent variable, the time, the dependent variable, the range at the height of his waist above the ground. We can talk about a domain and range for this, and I wonder if it asks that. Yes. Okay, yes it does. All right, so let's take a look at that in our packet right here. Okay, so again, it asks you to do that. Oh, look, the graph is right there, so maybe some of you figured that out. All right, let's talk about domain and range. So again, let's put independent and dependent variable on this graph. So the independent is always the x-axis. So here's our independent variable. Here's our dependent right here. Let's talk about domain and range. Domain is how far left and how far right. So this graph goes from 0 to 15 seconds. So here is one way to write that. And then our range is what's the lowest and what's the highest. So it looks like the lowest is a little bit above 1 foot off the ground, the bottom of that slide. So I'm going to just estimate, I'll say like 1.2 feet. And then it goes, the highest he is about, I don't know, I would say 9.7 feet above the ground. And there's an example of domain and range in a graph, in a story problem that we looked at. Okay, what's next? Oh, I should maximize this, I apologize. All right, fill in the blanks below to describe the graph. Use the graph and math vocabulary from the word bank. And I don't think we use all of these words, so let's fill this in. This graph represents Adam's experience on a slide. The blank is the time. All right, so we knew that that was the independent variable because his height depended on time. The blank is blank. It took Adam blank seconds to go up and down the slide. All right, so let's see, the blank is blank. Oh, the independent variable, dependent variable is height. The dependent variable is height. I don't think I have all the words there. It took Adam blank seconds to go up and down the slide. Ooh, I forgot already. And so that would be 15 seconds. The height of Adam's waist started how many feet off the ground? Okay, 3 feet off the ground. Then the height of his waist blanked, so increased, I would say, at a constant speed, rate, for about 4 seconds while he climbed the ladder. The height of his waist reached a blank height of 9.5. Ooh, I guess 9.7, I was close. Then the height of his waist blank quickly to a height, I would say dropped, decreased, to a height of 6.5 feet as he sat down. The height of his waist stayed constant for almost 5 seconds while he sat at the top of the slide. When he went down the slide, the height of his waist blank and reached a blank height, I would say minimum height. I would say decreased here. Okay, so it's, can you write a little story problem explaining the situation? So there's our last thing. Okay, and there is one more example, and I'll have you make the story for this one. So it says, the graph below shows the elevation, the height of a paper airplane as it travels through the air. All right, so again, what's the independent variable? Independent is the x-axis, is the domain, so here's the independent. Our dependent is our y variable, or elevation of the plane in this instance. Let's do domain and range one more time on a graph. So domain, what's the lowest x? It's 0. And then what's the highest? Well, on our graph is 15. I'm going to assume that this graph keeps going. So we'll say again from 0 to 15. If you said 0 to 8, because it kind of stops there, I would accept that too. All right, let's talk about lowest and highest y value for the range. Looks like 0 for the lowest, 20 for the highest. And it includes those values, so I put the equal sign there. All right, and then part 2, write a paragraph to describe the graph of the paper airplane. And again, you can use the paragraph on the front as a model. Use the math vocabulary from the word bank. So we could say something like, the paper airplane started at a height of 18 feet. It increased until it reached a maximum height of 20. It decreased, and then it decreased more quickly until it reached its minimum height at the ground. So you could say something like that. All right, so your assignment then is to review domain and range, and you're going to take a look at it in graphs, and mainly graphs, I would say. And there's a table as well. So your assignment will be the next 2 pages, 13 and 14.